spend a lot of time talking about electric vehicles. The instant torque, the battery range, how fast you can charge them.
hmm Those are the things that get people excited.
They absolutely are. But if you, our listener, are just starting your journey into understanding electric mobility, you pretty quickly realize that range is only half the story.
Exactly. When we talk about real long-term sustainability, there's this crucial question that often gets overlooked.
It goes way beyond the tailpipe.
Right. What is the actual environmental cost of building the car?
Yeah.
Of extracting all those raw materials, and what on earth happens to all those complex parts at the end of its life?
Because if we're talking about decarbonization, you can't just stop at the car itself.
You have to look at the whole cradle-to-grave life cycle. I mean, especially the resources consumed and the waste created during manufacturing.
Yeah.
That's really the next great challenge for the industry.
Okay, so let's unpack this. Today, we're taking a deep dive into a really innovative technology program from Mercedes-Benz. It's called Tomorrow XX. And it's basically a blueprint for how to make the entire vehicle, component by component, part of a genuine circular economy.
And this approach is so vital because it shifts the focus. It's not just about making efficient electric cars anymore. It's about redesigning the very foundation of how we do industrial production.
So this isn't about minor tweaks for efficiency.
Not at all.
Yeah.
It's a foundational overhaul of engineering, looking at resource use and circularity right from the initial design phase. And this raises a big question.
Which is?
Can an industrial product this complex truly achieve a near-zero waste life cycle? Or are there always going to be trade-offs?
And when you look at where they're starting from, they've already made some pretty incredible progress just within the factory walls.
Yeah, the numbers are impressive.
The company's already hitting a recycling rate of nearly 100% in their production waste. They've closed the loop on steel scraps, and now they're doing the same for aluminum scraps.
And that's a great operational benchmark. But this deep dive, the Tomorrow XX mandate, it goes so much further. It's all about promoting the decarbonization of all materials used in the vehicles. Across the entire portfolio, we're talking about moving deep into the supply chain.
So really digging into the nuts and bolts.
Literally. The process involves analyzing and carefully evaluating every single kilogram of CO2 produced for every component, even the hidden parts you'd never see. It's like a full accounting exercise for carbon.
So if they're committed to redesigning the car's entire DNA, how do you even start with that? Where does that engineering philosophy begin?
The whole methodology really rests on two fundamental principles: design for environment and design for circularity.
Okay.
What that means, basically, is that before a component even gets mass-produced, it has to meet certain criteria. It has to use fewer non-renewable resources, have a high percentage of recycled materials, and it has to minimize waste when its life is over.
So it's not just about finding some new green material. It's about making sure that the piece of plastic in your dashboard or the metal frame of your door
Is also ready for its next life.
potentially in another car.
Exactly. And that leads you right to the core challenge: disassembly. For recycling to be truly effective, the parts have to be easy to separate. You have to be able to sort the materials by type.
I noticed in the sources that the engineering teams kept coming back to this idea of monomaterials. Why is that so important for circularity?
The monomaterial advantage is a total game changer for recyclability. Think about it. When you mix different types of plastics or you bond plastic to metal,
Right.
that complex mixture becomes extremely difficult to recycle mechanically. Often, the only way to recover anything from it is through these complex, energy-intensive thermal processes.
Which kind of defeats the whole purpose of being green in the first place.
Precisely. Monomaterials, meaning a component is made mostly of a single type of plastic or metal. They simplify the entire process. You don't need that costly and time-consuming separation before you can melt them down or reform them into new products.
This is where it gets really interesting, I think, because we move from this big theory of circularity to these surprisingly specific, small examples that make it all click. Let's talk about the headlight.
The headlight is a fantastic micro-example of this new design philosophy. It shows how the smallest engineering detail can unlock massive environmental gains.
Right. So there's a promising research project to create a fully recyclable headlight. Now, for you listening, if you've never thought about this, a modern headlight is a complex thing. You've got lenses, frames, electronics.
And they're typically all glued together.
That glue, that's the problem.
That glue is the material killer. Once those parts are glued, they become one single non-separable composite. It makes them nearly impossible to recycle without just destroying the materials.
So the new design changes that completely by using screws.
Just screws. Instead of glue, they use mechanical fasteners to fix the lens, the frame, the housing, all of it.
That simple switch from a chemical bond to a mechanical one allows for rapid, damage-free disassembly.
hmm And for the first time, a modern headlight becomes easily repairable. Its valuable materials can be separated and recycled. It's a huge lesson. Sometimes the best innovation is just returning to the basics.
It makes that concept, designed for circularity, instantly clear. You're designing for the breakdown, not just the build. Another example they tackled was the interior door panel.
Right, which often uses ultrasonic welding.
And that creates another one of those difficult material mixtures.
Exactly. So they developed a new joining technology that makes it much simpler to separate those individual materials within the panel. Again, advancing recyclability without compromising safety or how it feels.
It's clear they're scrutinizing every single piece. The sources said they've already developed or tested over 40 new components and materials in just 2 years.
That's an intense pace. And it brings us to the materials that make up the bulk of the car plastics, metals, and tires. These are the highest volume areas where even small improvements can have a huge real-world impact.
Let's start with plastics. A modern car has, what, about 250 kilograms of plastic in it? If that's all mixed, it's a massive disposal problem.
It is. The focus is shifting aggressively from those mixed plastics to what we call secondary materials, materials that have already been used once.
Okay.
And one key innovation here is something they're calling the mono-sandwich PET. It stands out because it's lightweight and has a very high recycled content.
And this isn't just a lab experiment, right? This PE innovation won a major award for CO2 efficiency in 2024, and it's heading for large-scale production.
That's right. And you can already see this tech in action. For instance, seat covers and wheel arch liners have been made from 100% recycled PET bottles for a while.
Right.
Now they're extending that to carpets and floor mats. And that alone is projected to reduce the carbon footprint of those specific parts by up to 75%.
75%. That really shows you the benefit of targeting the material itself.
Mm.
So, moving on to metals. These are huge energy consumers, especially in their primary production. Aluminum is so important because it's light and strong, but
But globally, its production is one of the most energy-intensive industries there is.
yeah.
That's the trade-off. You save fuel with lightweight aluminum, but you spend a ton of energy creating it.
So how do they tackle that?
Well, the company already uses low-carbon aluminum, which cuts emissions by about 70% compared to the European average. And that comes from partnering with suppliers who use renewables like hydropower.
And the goal is to go even further.
Yeah, they're aiming for a 90% reduction by 2030.
And what about steel? That's the other behemoth. How do you make a material that has historically relied on coal truly green?
You have to replace the traditional blast furnace process entirely. The alternative they're focused on is direct reduction using hydrogen.
Okay, so for the listener, what does that actually mean?
It means instead of using carbon, like coal or coke, to strip oxygen from iron ore, use hydrogen gas. The only byproduct is water vapor.
So you're replacing a CO2 producer with a clean water producer.
Exactly. And when you combine that hydrogen process with electric arc furnaces, which can use a lot of scrap metal, and you power the whole thing with renewables,
You get virtually zero emission steel.
you get zero-emission steel. The car's structural bones are no longer a major source of carbon.
Now let's talk about something notoriously complex and bulky. Tires. Millions of them reach their end of life every year. What's the circular solution for old tires?
Tires are a huge, untapped resource, and they're tackling them with a mix of chemical and mechanical recycling. The chemical process is the most innovative part.
What does that involve?
Discarded tires are broken down via a process called chemical recycling into something called pyrolysis oil.
Pyrolysis oil. In simple terms, what is that?
Think of it like a synthetic fuel or an oil substitute that's derived from the rubber. That oil is then combined with certified biomethane, which comes from agricultural waste.
So you're combining two different recycled inputs to create a brand new material?
Precisely. And the output is a highly advanced recycled plastic with the same properties as virgin plastic. It's a genuine, high-quality replacement.
And I read that this plastic, derived partly from old tires, is now being turned into a next-gen luxury material.
Yes, this is where biotechnology gets involved. That recycled tire plastic is combined with bio-based proteins to create a high-quality leather alternative.
Wow.
This material has about a 40% lower carbon footprint than natural leather, And crucially, the plastic in it can be recycled again.
That is the ultimate closed loop. You're turning a worn-out tire, a notorious waste product, into a premium interior material that can be recycled again.
It is. And
Yeah.
beyond that, they're also recycling tires mechanically.
Mm-hmm.
Shredded tires are being used to produce sound-absorbing materials and vibration dampers for the underbody of the cars.
And we also see the circularity in smaller, really technical components like brake pads. I saw that they're using 40% material derived from used brake pads.
Yeah, by incorporating about 40% of that used material back into the new concept, they estimate a CO2 savings of up to 85% for that single component. It shows that even parts we assume have to be made from scratch can be radically decarbonized.
We've covered everything around the power source, but now we have to address the EV core, the battery. This is the elephant in the room for EV sustainability, isn't it?
Absolutely is. The battery pack is currently the single component with the highest carbon footprint.
Uh,
Because of the critical materials involved, lithium, nickel, cobalt, and the intensity of manufacturing, you need a multi-stage approach to really decarbonize it.
so for our listener who's focused on battery transparency, what's stage one?
It starts with power. The direct cell manufacturers they work with are required to use green electricity in their production facilities.
Meaning renewables.
Right. And they have to use energy-efficient processes and continuously reduce their emissions. You clean up the power used to build the battery before it even leaves the supplier.
And stage two focuses on the ingredients inside the battery.
Yes. The goal there is to increase the use of secondary, so recycled materials for both the cathodes and anodes in the cells. This reduces the reliance on new mining, which has huge environmental and ethical issues.
And finally, they're preparing for the ultimate closed loop for the battery itself.
To fully close that material cycle, they're accelerating construction of an in-house pilot plant in Germany. It's specifically for battery recycling. This plant is designed to recover those active materials, like lithium and nickel, and feed them directly back into new battery production.
So what does this all mean for you, the listener, who's just starting to learn about EVs?
It means that if you're exploring electric vehicles, yeah, understanding the motor tech is important, but understanding the technology of the materials,
Yeah.
how they're sourced, how they're reused, that is the true future of sustainability.
Right.
This deep dive shows that the focus has really shifted. It's moved from simply driving electric to driving electric cars that are built sustainably from the ground up.
The real innovation isn't just in the speed or the range, but in replacing a glued headlight with a screwed one, or turning old tires into a high-quality leather alternative. It's about seeing every end-of-life vehicle not as waste, but as a strategic source of raw materials for the next generation.
And that raises a really important question for all consumer industries, I think. If automakers can achieve a near-perfect material loop for something as complex as a car, with all its plastics, steel, and advanced batteries, what other industries are failing to adopt these same principles of design for circularity? This is a mindset shift that goes so far beyond just the car industry.
That is a powerful thought to end on, the wider implications of this kind of material science. Thank you so much for joining us on this deep dive into the materials of the future. We really hope this gave you a fresh perspective on what EV sustainability truly means.
It's been a pleasure connecting the dots on this.
And if you found this exploration of sustainable materials interesting and you want more shortcuts to being well-informed, be sure to follow the channel wherever you listen. We appreciate you trusting us with your learning journey, and we look forward to unpacking the next stack of sources with you soon.